about the Hadoop like for the past 2-3 years about the big data analytics and how it can be used, and it looks like the next future like data warehousing and SAP and everything like that. It's more than that. So really interested to know like what is the technology behind it and how it's actually like redesign the future for us. So, yeah.
Right. Great. Right. So let's move ahead, and before just jolting into the discussion, let me introduce myself. Let's say we opened a bank account somewhere in 2000. 15 years later, that is in 2015, let's say we approached the bank and we asked them for the past 3 months bank statements. Well, the 3 months bank statements we can expect in the span of half an hour or at most in the span of 1 hour, because it's not a big deal. Let's say we approached the same bank the very next year, asking them for the past 10 years bank statements, where the 10 years bank statements we cannot expect in the span of half an hour or 1 hour, because it's a well-known fact that the data will be moved to the backend, stored in huge magnitudes with Teradata, Netager, moving ahead with data warehouse, ETL, usually use SAP for data management systems, several BI tools for reporting. So simply I can say a huge process that goes by. And let's initially discuss what are all the problems involved with those traditional approach of storing the data sets and processing them. And then let's discuss how Hadoop can overcome all these data sets, handling of data set issues, and how Hadoop can give you the optimal solution with all these large data sets with minimal pricing and with extra features. So let's go ahead with that. So let's initially talk about the problems involved with the existing data storage and processing methodologies. Well, here I classified data as people data and machines data, a simple way, because these two are the major sources where we'll get the large dump of data sets from. Well, when I talk about the people data, with the people usually generate a large magnitude of data sets from the social networking sites, e-commerce, online reservation, online banking, and through several sources. And when I talk about the machines data, which is like RFID readers, GPS tracers, satellite communications, and the log files, which will be also at huge magnitudes. And a buzzword for all is, if you consider the history, organizations like Google, Yahoo, Amazon, because these are all the so-called giant organizations which usually deal with large data sets over the past. But it's a well-known fact for everyone that today, even I can say each and every organization is suffering from the problem of handling these sort of large data sets in their environment. And at last I passed a bold statement stating that existing methodologies were becoming inadequate in handling the large data sets. So let me kindly share you why I passed this bold statement and what are all the problems involved at each and every perspective. So let's initially address about data storage part. The moment when I address about data storage, the first and foremost word which will strike away our mind is nothing but RDBMS, which has been ruling the industry over the past 2 decades. But still, RDBMS has, I can say, a dump of constraints. So let's initially talk about the problems involved with RDBMS while handling the datasets. point one, there is no support for unstructured data. The moment when I say about an unstructured data, any data sets on which you cannot define any schema fall under the category of unstructured data. I can say simply image files, video files, audio files, HTML pages, log files. These all fall under the category of unstructured data, where RDBMS will utterly fail in handling those sort of unstructured data sets, because without defining the schema, you cannot ingest the data into that. So simply I can say RDBMS is going to utterly fail in handling the unstructured data sets. And point two, everyone knows that RDBMS is going to give you excellent performance when your data is at the range of lesser magnitudes. And when it reaches the magnitude of hundreds of terabytes or petabytes, you're going to experience a very degraded performance of RDBMS. And above all, we know that for our specific application, we'll lend the disk space from SAN storage, where the disk space will be allocated as LUN allocation, logical unit allocation. But since at the SAN perspective, whatever the disks, the physical disks used are FC disks, fiber channel disks, and SSDs, solid state drives, which are literally very expensive. Obviously, the storage was ought to become so expensive. So on the whole, when I talk about the data storage part, the problems involved are point one, there is no support for unstructured data. Two, expensive storage because of high-end hardware. So these two are the most sounding constraints at the range of RDBMS. All right, so since we don't have any alternative, we have been storing those data sets on top of RDBMS. Let's say once after the data sets were stored, we need to process them, for which, as I specified, the terminologies like ETL, data warehouse, SAP for data management, so everything comes into the picture. And I can say in a bold way that none of the technologies will work with cheap hardware. They literally require blade servers and Spark processors to work on, which are very, very expensive. And not only that, they were not open source. They were proprietary. You need to purchase the license and then only you can move ahead. So I can say simply, data processing became very expensive because of the high-end hardware and because of the licensing issues. And above all, if you want to process the data sets, you need to transfer them from the storage centers to the processing units, for which we need to seek the help of network again. And the term network comes up with a package of constraints. So let me share you, using FC cables, fiber channel cables, you can transfer the data almost at 16 Gbps. Just imagine 16 gigabytes per second. I can say it's an excellent speed. Though the data could be transferred at 16 Gbps, the disk cannot retrieve it at that much faster. Disk speeds are hardly struck at 500 Mbps. This is the speed at which your network could transfer at 16 Gbps, and this is your disk speed, hardly at 500 Mbps. And so it leads to a speed bottleneck problem. This is a major constraint. And it's a well-known fact that usually at the storage perspective, any flavor of Unix operating system will be used. Either AIX or HP Unix or Solaris, any flavor of Unix operating system. And where the block size of Unix file system is 8 KB. Let me share you a simple example. let's say that you uploaded 64 MB of data into the Unix file system. Just to store 64 MB, it's gonna consume 8,000 blocks because the block size is of 8 KB. If you want to retrieve your 64 MB datasets back, your disk head need to be moved from one block to another block and so on, all these 8,000 blocks. And the time taken by your disk head to retrieve the data from one block to another block is what we call as disk seek time. Because the block size is less, seek time is huge. So on the whole, let me initially list out all the problems together, whatever we discussed so far. Just one second. So the problems are: point 1, there is no support for unstructured data. And point 2, the disk seek time.
Oh, study with me, bhai. Sorry, इतने login होता भाई.
And point 3, network issues, I can say the bottleneck problems. And 4, expenses. So simply we can say that we require a new alternative, indeed a new technology which will support the unstructured data, which will vanish the disk seek time, which will eradicate the network issues, and that new technology, whatever we're going to use, should not be expensive. That should be cheaper in price. And that new technology which had all these features is nothing but Hadoop. Simple. So Hadoop can successfully handle your unstructured data sets, eradicating your disk seek time, vanishing your network issues, and at a minimal pricings. So let me talk how exactly Hadoop can do all these things in a successful way. And before just talking about it, let me address about this part as well, because I'm sure majority of you might have I can say not majority, even everyone might have come across the organization like IDC, International Data Corporation. According to the statistics of IDC, the world's data in the year of 2006 is 0.18 zettabyte. In the span of 5 years, that is in 2011, it increased 10 times and it came to 1.8 zettabyte. Where by the end of 2020, they're expecting this data to reach almost 40 zettabyte. And here I mentioned what a zettabyte is. So 1 zettabyte equals to almost 1024 cube terabyte. Simply I can say 1 zettabyte equals to almost 1000 cube terabyte, which is at 10 power 9 terabyte. Just imagine 10 power 9 is a huge figure. So let's list out. 40 zettabyte will be something around 40 into 10 power 9 terabyte. And if you start storing this magnitude of data sets into the so-called 24 TB drives, how many 24 TB drives do we require in order to store 4 into 10 power 10 terabyte of data? Not only simply storing it, we need to provide the redundancy also. And how many $1 million do we require to process these sort of these magnitude of data sets with the existing high-end hardware and the licensing issues? And how many days do we require to transfer these data sets with the existing bottleneck problems? The jargon itself conveys us that we are choosing a wrong path. Indeed, we require an alternative. And Above all, 80% of this data set, whatever we're going to talk about, gonna be unstructured. And we, the people, are generating these unstructured data sets from the social networking sites where we usually upload images, videos, likes, comments, shares, tags, applications, tweets, chats, posts, whatnot, everything. And we classified the mails as semi-structured data because if you consider an email, you'll have to CC, BCC, and from, where you can define schema on the mail IDs and you can store it, not a big deal. But can we define any schema on the text body of the mail? And majority of the emails may have attachment and many may not have any attachment. And that attachment might be again unstructured. That could be an image file, could be a video clip, an audio file, a PDF file, which will be unstructured. But definitely the mail IDs are structured, and so it was made under semi-structured data set. And even the machine's unstructured data as RFID readers, GPS tracers, satellite communications, and the log files. So far we have some of the people here who have been working on top of Java, where they might have the privilege of working with the web applications, definitely, where while running with web application at the range of the web server, the log files, the access log files will be usually disabled because they will be generated at huge magnitudes. But if we have the technology of dealing with these access log files, we can trace out the particular user behavior and we can come up with a solution. And the same pattern for the clickstream analysis, which we followed for Flipkart, where we generated 38.6% of their revenue by processing these log files. That is again through Hadoop. And before exactly addressing what Hadoop is, I need to talk about this so-called giant term, big data. Well, let me share you. Big data is not at all a technical term. Point one. Big data is not at all a technical term. Any data sets having several characteristics can be addressed as big data. And the characteristics that are to be possessed by the data sets in order to get addressed as big data are like this. It's volume, velocity, and variety. Where volume talk about the magnitude of the data set, whether your data set is at the range of terabytes, petabytes, exabytes, or even at the range of zettabyte. Magnitude will be addressed as volume. And velocity talks about how much faster the data sets are getting generated and how much faster you need to process them in your environment. And variety talks about the type of the data set, whether it is structured or unstructured. If your data sets are of huge magnitudes, which are getting generated at high speed, which are of semi-structured or unstructured, you can address your data set as big data, which is $1 million question in front of the industry. And it is Hadoop which can handle this big data sets in an excellent way and which will vanish all the problems whatever we discussed so far. So let's discuss about it. And before addressing what exactly Hadoop is, let me share you. Hadoop is always at a cluster environment, where a cluster is nothing but combination of nodes connected across the network, and a node is a simple nothing but a computer. So I can say simply a cluster is nothing but combination of computers connected across a network. Let's say you purchased 100 computers and you joined them across the network. So I can say yours is a 100 node cluster. The moment you install Hadoop on all your 100 computers, it's gonna become a 100 node Hadoop cluster. Simple. And once after you install Hadoop across your cluster environment, it's gonna accumulate its two major components across the cluster, which is nothing but HDFS and MapReduce, where HDFS stands for Hadoop distributed file system. Well, distributed file system is not new. Everyone knows. But I can say Hadoop distributed file system is something new where the default block size is 64 MB. Just imagine 64 MB is not a simple block size. Let's say we're going to store 128 MB of data over the Unix file system, for which it's going to consume 16,000 blocks because the block size is of 8 KB. The same 128 MB of data on top of Hadoop going to consume only 2 blocks because the block size is of 64 MB. Imagine about the disk seek time in this case, moving the disk head across the 16,000 blocks, and imagine the disk seek time across this, only across 2 blocks. So since the block size is huge, obviously seek time is less. So I can say because of the large block size, disk seek time will not be an issue on top of Hadoop. So the disk seek time got vanished because of the large block size, 64 MB. Even you can configure it. You can make it to 128 or even with 256. And whatever the data you're going to store will be stored directly over the file system. So since you are storing the data directly on the file system, I can simply say there will be a support for the unstructured data sets. Even that's the major reason why we could able to store images, songs or movies on your laptop or on your PC, because we are storing them directly on the file system. And Hadoop also does the same. So simply I can say you have the support for unstructured data as well as the disk seek time got vanished. And let me share you. Let's say you have a data set of 1 terabyte. Since you have a 100 node Hadoop cluster, the moment when you want to handle this 1 terabyte of unstructured data, you will upload this to Hadoop environment, where your 1 terabyte will be made into 64 MB blocks. And these blocks, 64 MB blocks, will be scattered across your 100 machines, across the distributed file system, the 64 MB splits. Once after the data was scattered across all your machines, if you want to analyze it, if you want to process it, you'll define a MapReduce job, where this MapReduce job can be defined either in Java, Ruby, Python, Perl, or even in C++. But as majority we have Java programmers, people usually go for Java MapReduce. They're going to make a jar file, and it's your jar file which will travel towards your data sets, towards the machines on which you have your data sets, and it will process the data sets there itself. So I can say simply you're storing the data on the cluster, and even you are processing the data on the same cluster. So since your storage and processing were made on the same cluster, we can simply convey that the network issues are vanished on top of the environment, since storage and processing at the same hub. And above all, whatever the machine that you are using on the Hadoop environment is a cheap hardware. Hadoop does not require anything like blade servers or Spark processors to work on. It will work with the basic hardware, and that too it's an open source. Indeed, since it works with the cheap hardware, on 5th day of our journey, we're gonna install Hadoop on your laptop or on your PC, because your laptop is a cheap hardware and my PC is a commodity hardware, and Hadoop works with that, and that too upon open source. If you consider on the whole, disk seek time got vanished because of the 64 MB block size. It has the support for unstructured data because storing the data sets directly on the file system. Network issues got vanished because of the storage and processing at the same cluster. And the expenses got drastically reduced because of the cheap hardware and the open source. So what else do we require? All the 4 constraints were no more on top of Hadoop. And this is what I've been talking about: data storage and data processing at one hub. This is nothing but your cluster. And this is the fastest processing. This is not what Vignesh is boasting about Hadoop. This is IBM's declaration where we processed 1 terabyte of unstructured data using RDBMS, for which it consumed 28 hours to process it. The same 1 terabyte of unstructured data using Teradata consumed 6.5 hours to process it. The same 1 terabyte of unstructured data using Hadoop 180 node cluster consumed 3 minutes 27 seconds to process it. And the same 1 terabyte of unstructured data using the same 180 node Hadoop cluster, but with the latest architecture called as YAN architecture, could make it in 1 minute 19 seconds of time. That at a cheap cost. This is how exactly Hadoop can handle the data sets. The moment you have your big data, you'll upload it to the cluster environment, where your big data will be made into 64 MB chunks, and the chunks will be scattered across the cluster like this in a distributed fashion. So I can say simply, the data was being stored across the cluster in a distributed fashion. And if you want to process it, you'll define a jar file in a MapReduce program, and you'll trigger it. Observe your data is stagnant, and it's your jar file which will travel towards your data sets. You'll not move your data. It's your computation which gonna approach your data sets. Because a node is nothing but a computer, since you have RAM and processing capabilities at each and every computer, using those RAM and processing capabilities, it's gonna process these data sets. So if you observe, your data sets are being parallelly processed across the cluster. But if we delve deeper into each and every machine, still more, it's gonna create several JVM instances. It's gonna create several JVM instances using which the data will be still more parallelly processed like this. So it will create several JVM instances where it will split the data sets further, called as input splits, and it will process the data sets still more parallelly like this. So I can say simply, Hadoop is a massive parallel approach of handling the data sets. It's not a simple parallel approach. And this is the core concept of Hadoop, where it's easier to move the computation rather than moving the data. And that's what we have been doing here. It's your computation which is being moved towards the data sets. And it's a massive parallel processing for the ease of handling the large data sets. And it's easier to deal with small data chunks rather than dealing with big data sets. That's where we went on with the distributed approach, and above all, it works with the cheap hardware. And I'm sure majority of you might have even come across these words. As we discussed, once after the data was stored in the distributed file system, in order to process it, we'll define a MapReduce jar file. We'll define a MapReduce job which will process these data sets in a parallel way. Let's say for the people who are not from any programming background, because MapReduce definitely requires any programming language. As discussed, Java, Ruby, Python, Perl, or C++. Any of the programming knowledge is required to design the MapReduce job. But for the people who are not from any programming background, but still want to work with Hadoop, yes, they have the alternative. They have the layers of Hive and Pig, where Hive has its own query-like language called as Hive query language, for which whatever the query you pass, that will be generating the MapReduce job. So simply I can say Hive is an alternative approach of handling the data sets. Query you pass, that will be generating the MapReduce job. That's Hive. And even Hive can be integrated with any of the BI tool like ClickView, Tableau, Spotfire, Karmasphere, and can generate the report. So you can use this for visualization as well. That's Hive. And let's say for the people who are not even from SQL background, neither from SQL background nor from programming background, but still want to work with Hadoop, for them they have another alternative called as Pig, which has its own scripting like language called as Pig Latin. And whatever the script you define, that will be generating the MapReduce job. And you need not to define lines and lines of code here, which Pig can be utilized even for the ETL actions. So I can say simply Hive and Pig are the alternatives to design the MapReduce jobs. And Scoop use a utility tool to import the data from different sources, especially from RDBMS to HDFS, where using Scoop you can import the data from Oracle, MySQL, SQL Server, DB2, PostgreSQL, even from Teradata, NetAsia to HDFS, to populate the data sets from different sources to HDFS. That's Scoop. And Avro is to deal with serialized files, encrypted files. And we have HBase, the NoSQL database. I'm sure almost everyone might have heard about this term, NoSQL, NoSQL, where the name itself conveys us NoSQL, not only SQL. Here you will not have anything like normalization, no primary keys and no foreign keys, where your data set will be stored in key value pairs, and it can store the unstructured data sets. And it's a column oriented storage, not a row oriented accessibility. And there are almost, I can say, 150 NoSQL databases, out of which the most sounding are HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, Accumulo, Dynamo, Bigtable. So these are all the most sounding NoSQL databases. And we have something called as Zookeeper for the coordination, which coordinates across these ecosystem components. Each and every ecosystem component, whatever I addressed, is an open source. Of course, Hadoop itself is an open source. But let's say that you want to build a 100 node cluster. So you'll definitely purchase 100 physical machines. And in order to build it, you'll download Hadoop from Apache. Once after the download was done, you'll start installing it and then configuring it. Let's say while configuring, you are struck with a problem. Definitely you cannot expect any support from Apache. And once after you install Hadoop, you'll have only these two components, because MapReduce and HDFS. These are only the components which will come by default for Hadoop. And if you want to work with Hive, again you need to download from Apache, install it, configure it. If you have any issue, no support. Work with Pig, install, configure. Issue, no support. So simply, you'll not have any support at each and every perspective. And since this is an open source, you cannot even expect a well-versed user interface. Majority is based on command line. And owing to these constraints, there were several distributions, I can say several organizations who came forth, where these gonna give you excellent technical support, a very good user interface, and they offer all these ecosystem components as a package. Where some of the distributions are like Cloudera, Hot on Wix, IBM Big Insights, Microsoft HD Insights, Amazon Web Services, EMC Square's Greenplum, Astrodata from Teradata, Oracle Big Data, Intel Hadoop, Mappa Distributions. Almost there are 14 distributions. No matter whatever the distribution it is, The basic core concept is the same. They'll have the same HDFS, same MapReduce, same ecosystem components, but the difference is their user interface varies and the support pricing varies. And the most sounding distributions are Cloudera, Hortonworks, Amazon Web Services, MapR, and somewhere you can even hear about the EMC Screenplum and HP Vertica as well. So these are all the most sounding distributions. Irrespective of the distribution, as I said, you'll have the same features. I can say simply, this is just like the Linux, and these are all the different flavors of Linux. Just like SUSE Linux, RHEL, Ubuntu, CentOS, just similar to that. And these are all the organizations who have been with Hadoop. And as per Gartner's report, by the end of 2016, almost 91.6% of the industry gonna migrate to Hadoop. And this is a simple introduction. And now, if anything is unclear, you can kindly unmute yourself and you can fire me with your questions, please.
Hi Vignesh, this is coming.
Yeah, hello, please tell me.
Is Hadoop for online transactions, or it's like basically
No.
at the back end, the data housing side?
No.
So,
Hadoop is not designed for OLTP. It's only meant for offline analytics. It's not meant for OLTP. You don't have anything like asset properties or commit rollback operations on top of Hadoop. So it's
okay, it's just like processing of data, selecting of data, that's all.
Absolutely, it's just meant for the processing of data sets, not only confined to your RDBMS, but also your log files, even your HTML pages, but also at the range of unstructured data sets. So it can handle that, but it is not meant for transactions. So far, there is no support for that.
Okay.
So definitely your application database will not change. It will still persist. And soon we are expecting that feature, compatibility with transactions as well.
And currently this HDFS is currently used in like Facebook or Twitter, or it's like something new that is being looked into by all the organizations?
No, HDFS is the basic layer. HDFS is nothing but the storage layer where it is widely used. Whenever you have Hadoop, definitely you have the HDFS by default. So when you load the data sets, they'll be stored in the HDFS layer only, where you can even replace that HDFS with the other layers like QFS, Quantcast file system. There were other file systems which you can replace them up, but it's widely being used for HDFS only.
Hi Vignesh,
Yeah, please.
this is Sandeep. So looking at this, we see that any kind of data can be loaded into the HDFS.
Yes.
So is there any restriction or exception data that we cannot load into Hadoop?
Absolutely not. You can store any kind of data sets. There are no such constraints. You can load any kind of data sets on top of Hadoop environment. When I say unstructured, it addresses global simply. So it can load any kind of data sets. There are no such constraints.
Okay, and actually I'm working on BI area. So as you have mentioned, we connect Hive
Yes.
to any BI tool and use it for visualization.
Yes.
So do we cover that concept in the course in the upcoming classes?
Here we're going to talk about one of the freeware BI tool, because Kibana for the visualization.
Okay.
It's one of the visualization tools. So we're going to seek the help of that, because other BI tools definitely will require license. And so we'll just come up only with this Kibana. You can even find that Kibana is one of the visualization tool for which the backend will be Elastic Search Engine.
Okay. Okay.
Hi Vignesh, this is Aditya.
Please.
Yeah, I mean, I'm just trying to see the architecture level, like retrieving data in OLAP. So if you see Teradata, it uses a virtual disk at the time of retrieving data from physical disks, whatever it is.
Yes.
So what type of processing does Hadoop does at the time of retrieving data? Is it
Right.
virtual or physical?
No, definitely it's not physical again. So simple. Let's say, as I specified, Hadoop is a framework actually. It's not an operating system. So when we discuss about a 100 node cluster, in order to install Hadoop, definitely prior installing to Hadoop, we need to install any of the operating system. Let's say we went on with the Unix across all your 100 machines. The moment we install Unix operating system, the Unix file system gonna be accumulated across all your 100 disks, where you'll have the 8 KB chunks. Once after Hadoop was installed, Hadoop gonna overlap that Unix file system, where one Hadoop block, 164 MB block, gonna have 8008 KB blocks, and definitely the data should be stored finally on the physical disk, on the mechanical drive, where the data will be finally stored on the Unix file system only on the 8 KB blocks. But regarding the disk head need to be moved only at the range of 64 MB splits, because all these 8 KB addresses gonna be stored on the 64 MB chunks. So that's how it's gonna eradicate the disk seek time. That's the basic fundamental concept. We'll delve on top of it.
Okay. That means at the end, it follows the node technology just like in Teradata, right? I mean,
Definitely.
we have AMP concepts. So similarly, the node concept is there in Hadoop, right? That's
Yes.
what you are saying.
So here we can say that, let's say if you upload any kind of data sets which are not in the factor of 64 MB, you need not even worry regarding the disk wastage. So it's gonna optimally being utilized.
Uh,
So at the range of
okay.
once I say optimal utilization, definitely it will gonna it's gonna append these things, and definitely it's gonna give you the optimal solutions, which indicates it itself is a virtual virtual layer on top of the Unix file system.
Hello, Vignesh. This
Yeah,
is
please.
Uday.
Please.
So I joined this presentation a little late because I saw in one of my emails that this would start at 8 a.m. IST. So anyway, my question is, so you mentioned that the data is not moved and the data is stored in the 64 MB chunks in all the different nodes.
Yes.
So when you want to perform an analytics, like when you want to generate
a report
a report or a calculation, so how will you generate it without unifying the data from all the nodes? Like
that's
you
what
said that
yeah, I catch the point. So that's what the MapReduce does actually. So let me share you. So here you have your data sets being stored across the cluster in a distributed fashion. These are all your 64 MB splits.
Okay.
So at the range of defining the computation, you need to specify, let's say these are all the chunks, some of the data sets. And while defining the computation, that's making the jar file, you need to define 3 classes: mapper, driver, and reducer. Where driver is nothing but the configuration. I can say it's a main class. Mapper is the place where your core logic gonna be applied. So if you want to perform the metrics, so those metrics will be performed at the range of mapper logic. So here the same logic will process these two 64 MB splits, coming up with some data set. After processing these 3, it's gonna come up with some output. After processing these 2, some output. And whatever the output you got from all the mappers gonna be given as input to reducer wherever it has some slot availability. We'll talk about it, how exactly the reducer and mapper actions will perform. The output, whatever you got from the mappers, gonna be aggregated on a particular node. This is what we call as reducer action. So once after the logic was performed, as you specified, the output of the mappers gonna be aggregated at the reducer phase. That's what the reducer does. The reducer output is nothing but the final output.
Okay. So I mean, so I have one more question. So
please.
It means that suppose you have like a billion records, coming to you. So you want to store billion records in the HDFS system. So are you going to store like in 64 MB chunks? Are you going to store one full record in one place, or are you going to
Good question.
If it depends, so it cannot perform this activity on a local basis. You have to, if it's split, then you have to run the mapper on two nodes at once, isn't it?
No. For that, we have an arrangement by record reader. So let's say I got the point. Let's say some ID, some name, some salary. So let's say these are all some of the records. So your question is, will it store only like this, or let's say the data was stored like this, right?
Right.
So always at this point while processing, you have some component called as record reader, which will catch up this issue of line break. So it will always look for the end of the line character, where definitely at this record end of the line character is missing. So this is gonna convey where the next split is. You have some management here where it's gonna fetch this part as well, storing it in the cache, and only these records will be processed. These do not have line starting, so these records gonna be processed, which will resolve the issue. So you need not to design any specific logic for this. It's gonna be handled by default.
Okay. So the data is stored on a row level basis, but not on a by columns, like the first.
So you can you have different formats. So when I talk about by default, when you come up with the HDFS perspective, it's gonna be stored like this. And if you manually mention at the range of Hive, for the optimization, you have some of the formats called as row columnar format, RC file format. If you specify for RC file format, then the data gonna split across the columns as well. So that gonna be stored with another column and all the things. But by default, it comes up with the row splitting only, not with the column perspective.
All right, Vignesh. Thank you.
Yeah.
Vignesh?
Yeah, please.
This is Veera. I have one question. Like, do you save this data? I mean, daily we'll get an incremental data, right?
Yes.
So do we store them in a place and do all the referential integrity checks and all, or like?
You have such privilege. Point one, by default, when you go for Hadoop environment using Scoop, whatever the incremental data that you got from your RDBMS will be imported to the Hadoop environment, that is HDFS environment, and then processed. So let's say you don't want to store the data sets. Let's say a simple like AO messaging system where the rush of the messages are huge and you want to process them on a streaming way without storing them. So you can seek the help of the components called as Storm, and the messaging you can ingest with Kafka or RabbitMQ. So they'll not store it. On fly, they're gonna give you the output without storing the data sets.
Actually, what happened is like we have a daily batch process going on from midnight to midnight.
Yes.
And so if we extract some incremental data the previous night, and some of the tables were not loaded at midnight, So we'll be pulling that data, right? So in that case, we'll miss some of the child records because parents were loaded previously and the childs will be loaded last, right? So if we miss that, and they'll go in the next day batch cycle. So do you do like how you handle that scenario in Hadoop? So it will, while loading, it will give you an warning kind of thing, or
Which thing? Can you please repeat your thing once more? Your question. So let's say you have you're ingesting the data set from any of the RDBMS, let's say MySQL, where step one you ingested, let's say 1 million records for the first import. Let's say next day, as you specified, for every 24 hours, for the next 24 hours, you have let's say 150 records updated or modified. So you're gonna import only those 150 records. You'll not import all those again 1,150,000 records, right? Then what's your question once after importing them?
So actually what happened is, suppose like we had an batch process going on in ETL today, and the source systems were getting loaded into RDBMS.
No. Just give me a moment. Source system were getting loaded into RDBMS. So you're exporting the data from your HDFS to RDBMS.
No, my source is Oracle database, and we are extracting data from there, and we are sending data to HDFS.
So sync is your HDFS, and your source is RDBMS.
Yeah, RDBMS, and so the tables are getting updated in the midnight, right? So all the ETL process is going on, and we loaded the data. And so what happened? So if we miss some of the tables data today's extra.
No, just give me a moment. So let's say now you have 1 million records. Now the time is, let's say 11 p.m. At 12 p.m. you have your job running on, let's say. So you have 1 million records imported at 12 p.m. Now next day is 12 p.m. Tomorrow's 12 p.m. Let's say 150 modifications were made. So you're gonna import only those modifications, right?
So if the previous source table was loaded lately, after 12 p.m., after 12 a.m., that load is still going on. So we'll be pulling only till 12 a.m., right?
Exactly.
Our load starts
only
12 a.m.
till that moment, yes.
Yeah, so we miss some of the child records which are loaded after 12 a.m., right? So those will be
point thing, just at that moment, in order to speed up the process, you can customize the number of mappers, whatever you have. Point one.
Okay.
That's the point. And when you go for the incremental import of scoop, you have something called as last modified import. You'll have last value stored in the script. You'll finally have the last value. So from that last value, you can import the data sets again. So definitely you'll not have issue of skipping those records. Those records will not be skipped out. You can utilize the last modified import of scoop, increasing the number of mappers, which will resolve this issue.
Okay.
But definitely that should not be a big deal. Just look into that. It will not create such issues. If you give the last value, definitely it will import all those records from which the last record was imported, and from then it will going to import all the records, whatever the modifications were made.
Okay.
Yeah.
Thank you.
Any more, or still anything unclear? Please. You can unmute yourself and you can shoot me, please.
One small question, can I interact Hadoop using mainframe?
Interact Hadoop using mainframes, because here mainframe perspective, you're gonna use some of the database. You will be having, I think, DB2, right? Your database.
Yeah.
So
yeah,
you
DB2 is there, but that is Yeah, IBM DB2 is there, but in today's world, maintaining DB2 as a OLAP is a cost here, right? Because it uses physical memory directly for processing. So that's right. Alternatively, we use Teradata here. So similarly, can we use Hadoop?
Replacing your storage with Hadoop instead of going ahead with Teradata.
The purpose is for data warehouse. I'm going in that way, actually.
If that was the case, then definitely you can go ahead. But regarding the integration part of mainframes with the Hadoop infra, I need to look on, because we did not work on that criteria so far. But whatever we got is, yeah, please.
Yeah, I mean, my question is, can I connect Hadoop directly from mainframe?
It's possible. You can do that.
Okay.
Anything still unclear? Right. So I hope, yeah, please tell me, Mr. Charan.
Yeah, like basically I'm working in ETL application Informatica. Like how can this Hadoop can be used to replace the existing ETL? Is it possible?
Simple. So at the range of ETL actions, so on top of Hadoop environment, you're gonna have the ETL actions through pig, and even your Informatica can be integrated with Hadoop to perform the ETL actions. So simply the data sync layer, whatever you're using earlier, can be replaced with the Hadoop environment, which will give you the cheap storage and processing capabilities. That's where you can find. So if you look on with one of the best example with Autodesk, where they replaced the existing ETL layer with the Hadoop infra or the data warehouse, you can look on to that example, which will I think it will be available even in their portal also. I think they uploaded that in their temple. So they replaced it. Autodesk.
Okay.
So it has they were using this. So Hadoop can perform your ETL actions, as well as it can be used as your data warehouse infra. And for the accessibility layer, you can use any of the NoSQL databases, and you have one much more, I can say, sophisticated layer, even as predictive analytics by the Mahout and the text analytics layer. So you have all those features embedded on top of Hadoop infra. That's the major reason why organizations are going to look forward for this. Right? Anything more or anything still unclear? Right. So I hope I'm clear. So let me sign off, and we shall meet later if everything goes fine. So we shall meet. The batch gonna be started, I think, from the upcoming Thursday of IST. It's the same time, 7 to 8. That is from 11th June 2015 IST. So if everything goes fine, we'll just move ahead, continuing our discussion.